Alright everyone, welcome back. We're just going to finish off chapter 5. We're going to look at word problems for 5.4 and 5.5, which were solving rational equations and inequalities. So we'll just jump right in here. Example 1. I bought a case of Math Rules hats. So here's my case of hats. And it costs me $300. And we'll say I bought X hats. I don't know how many. I kept 2 hats. One for myself, and I gave one to my friend Mr. Gerardo. I sold the remainder of the hats for $345, making a profit of $3 per hat. Now that per hat's kind of important here because I don't know how much we made. We just know that we made $3 per hat. So we're going to have to go through and calculate that because the amount that we bought was not the same as the amount that we sold. So we can't just subtract those ones. And you'll see here. But one thing that we do know is that revenue minus cost is equal to profit. That's always been true. We've worked with that before. So we're going to go through this. So revenue is the amount of money that I took in. So because profit is in per hat, we're going to have to make revenue and cost also per hat. So the revenue per hat minus the cost per hat is profit per hat. So revenue per hat, we know that I sold them for $345 and I sold X minus 2 hats. In terms of the cost, it cost me $300 to buy these hats and I bought X hats. And the profit per hat, well, it tells me that. I don't have to do any calculations. It just says that we made $3 per hat. So what I want to do is solve these ones. What we're going to do is we're going to combine the two fractions over here on the left. We're going to get common denominators. So when I do that, I'm going to have to get an x factor on this first fraction. I'm going to have to get x minus 2 as a factor on that second bracket. So we're going to have x minus 2 times x as my denominator for those when I combine the left side. The right side is still going to be equal to 3. But now on top, what do we have? Well, I have 345 times x, which is 345x. I'll zoom out here a bit. Then I have 300 times x and 300 times negative 2. But remember, we're subtracting that second fraction. So it's subtract 300x minus 600. So we're getting our equation closer and closer to what we want it to look like. What we're going to end up doing is now distributing in this negative. So what's that going to happen, or what's going to happen there is we're going to have negative 300x and plus 600 when we distribute inside. So in order to save some space, just do it right here. Like so. Now what I'm going to do is I'm going to add my like terms together. So I see 345x and negative 300x on top. So when I add them together, I'm going to get 45x plus 600. And that's just simplifying that numerator. X times x minus 2 on the bottom is equal to 3. Now in this case, I can multiply both sides by the denominator because it's an equality. If it was an inequality, we couldn't because we don't know if the sign, if the greater than or less than sign would change. In this case, it's an equal sign, so I can multiply both sides by x times x minus 2. So essentially, and same thing over here, x minus 2, so these will end up canceling out. So we'll continue through here. We'll end up with 45x plus 600. And when I distribute 3 times x, 3x squared, 3 times x times negative 2. So you see that now we just have a simple equation with no fractions in it. We need to get all of our like terms onto one side. So what I'll do in this case is I'll bring all the values to the right side because I see 3 over here and it's positive, and usually I like to work with it being positive. So we're going to start with 3x is already here. We're going to have negative 6x, negative 45x, plus 600. minus 600. Add my like terms together and try to factor it. So when I add my like terms together, we have two of them in the middle, negative 51x minus 600. And from here, we're going to factor the last one. We have 3 is a common factor of each of them. And lastly, we have a trinomial. We look for two numbers that multiply for negative 200 and add for negative 17. We know that negative 25 and positive 8 are two numbers that would satisfy that. And finally, we can solve this question to find out my values of x, where x is equal to 25 and x is equal to negative 8. So we go back to the original question. We want to adjust and see, do those answers make sense in this case? So the question was, how many hats were in the case? X is equal to negative 8. That one doesn't make sense because how do I buy negative 8 hats? So we eliminate that one. 25 hats, yeah, I can buy 25 hats. So that must be one of my answers, as long as it's not a restriction from my original question, and I know that because fraction on the left only has a restriction of 2. Fraction on the right only has a restriction of 0. None of them are 25, so I know that I must have bought 25 hats. Therefore, Mr. Mulrooney bought 25 hats. And I can draw myself wearing the hat with Mr. Gerardo, two best friends. And there we go. So that's the first one. You'll see that some similarities exist as we work through these problems. This one says, Nathan takes X minutes to line the field of our school, and Paul takes 10 minutes longer. So like X plus 10. Together, the gentlemen can line the field in 60 minutes. How long do each of them take on their own? So I want to know what is X for how many minutes Nathan takes, and I want to know what it is X plus 10 for how many minutes Paul takes. So if we were to solve this one, what we need to do is put them into the same unit. So we might say, how much of the field can they line per minute? So how many fields per minute they can work with. So in a case like this, we'll end up having Nathan. We know that he can do one field in X minutes. I know Paul, he can do one field in X plus 10 minutes. Together, that's why I'm adding them, we know that these guys can do one field in 60 minutes. So we want to solve what X is. If together they do the field in 60 minutes, well, alone they're probably going to be longer than 60 minutes. And you'll see that from this. So what we're going to do is treat this one just like the one that we saw before. Fields per minute that we've got here. We're going to combine our fraction over here on the left. In order to get that as my common denominator, I'd have to have a factor of X plus 10 included on this side. And on this side, I need a factor of X. So if that's the case, my numerator will be 1 times X plus 10 for the one that's on the left, which is just X plus 10, plus, the plus comes down, 1 times X is just X. So we combine those two fractions. I can add the two like terms on top. I see X and X, so I have 2X plus 10. And then from there, what we can do is cross multiply, just like we saw before. When we cross multiply, we take whatever's on the top, multiply by the bottom times the top, and make them equal to each other. So in a case like this, if we have 60 times 2x plus 10, if we have 1 times x plus 10, well, that's just x times x plus 10. Now we see it looks like equations that we've solved before. We have no fractions in there anymore. We can distribute inside the brackets. X squared plus 10x. Get our like terms all onto the same side, so it doesn't matter if we bring it to the right side or to the left side, as long as they're on the same side. So when we do that, we get x is equal to x squared minus 110x. And then we try to solve this quadratic that we have at the bottom. Unfortunately, we can't factor it, because there are no two factors that'll multiply for negative 600 and add for negative 110. But we know what we have to do in that case. We use quadratic formula, where a is equal to 1, b is equal to negative 110, and c is equal to negative 600. So this one's not going to work out to a nice whole number, but you need your calculator potentially for this one. But remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I'm putting this in the quadratic formula, negative b, so negative 110 is 110, plus or minus the square root of negative 110 squared. Put it in my calculator, 110 squared, we get 12,100. Minus 4 times 1 times negative 600. So 4 times 1 is 4, times negative 600 is minus or negative 2,400. All of that over 2a, which is just 2 times 1, which is 2. And then from there, we're going to put the discriminant into our calculator. So we're going to have 110 plus or minus. Keep in mind, we're subtracting a negative, which is like adding. When you put them into your calculator, you should get 120.4 or 120.42. In this case, we'll just round it to nearest whole number because we're dealing with relatively large numbers. And I'm going to put these into my calculator. One answer by adding and one root by subtracting in order to find out what our answers would be. So 110 plus 120 divided by 2, we would get x is equal to 115. And x is equal to 110 takeaway, which is about negative 5. If you kept all the decimal places, you'd have something really, really close to these ones. Now we have to ask ourselves, do these answers make sense? Now keep in mind what x was. X in the question was how long it took Nathan to line the field. So it does not make sense for him to line the field in negative 5 minutes. That would be spectacular. So it must be this one over here, 115 minutes. For Paul, he took 10 minutes longer, so he must be 125 minutes. And we can write a sentence to that effect here. Nathan lined the field in 115 minutes, almost 2 hours. And Paul took 125 minutes because he was 10 minutes longer. Together, they did in 60 minutes. However, alone, we know their amount of time that they took. So a little bit of, quite a bit of algebra in this one, but at the end of the day, it comes down to checking those final answers, making sure that they make sense in terms of the problem, and making sure none of them are restrictions, which they weren't. And the last one. Alright, and the last one that we have here talks about Sean. He's producing video games and determines the total cost of producing video games is this, 80x plus 150, where C is the cost and X is the number of video games he produced. Where X is equal to 1 refers to 100 video games because it's in hundreds. Determine the number of video games his company should produce if he wants to keep his average cost under 100 games. Well, average is equal to total divided by how many? So in this case, his total cost is C of x. And how many is he producing? He's producing x games. So we need to have the total cost divided by x, which is 80x plus 150 divided by x, and we want to keep that number less than 100 because I want the average cost per game. Right, we take our total cost divided by number of games, that's average cost per game, divided by, that's why we have to divide by x. So this is the equation that we want to solve here. In this case, we can't multiply both sides by x because if we try to multiply both sides by x, x could be positive, it could be negative, we don't know, which means this sign could flip, it may not flip, we don't know. So we don't want to do that. What we're going to do is we're going to take the 100 and bring it over to the left side and incorporate it in that fraction that way. So if I bring the 100 over, it's just going to be subtract 100 over on the left side here. From there, I need to incorporate that 100 into the fraction. Right now, 100 has like a 1 on the bottom. But if I wanted to have an x, I need an x factor on both sides. That way they both have common denominators of x. So that becomes 100x over x over on the left side, on the middle part of the equation. So we'll have a common denominator of x. We're going to have 80x plus 150 minus 100x less than 0. Add my like terms together, we have negative 20x plus 150 because we have those two x's on top. We have x on the bottom less than 0. So that's our equation that we're working with. We can try to factor the top a little bit more. Maybe we can take out negative 10, but essentially that's the equations that we have for now. But since it's an inequality, remember we need a factor chart in this case. And our factor chart is going to be broken up by our vertical asymptotes, the values of x that make the bottom 0. Well, that would be 0. And our x-intercepts, the values that make the top 0. So in this case, if I'm trying to find out the value that makes the top 0, it'll be 150, or negative 150 over negative 20, which if I divide them is 7.5. Make that a little bit better there, but 7.5. So I'm going to go from negative infinity to positive infinity. However, I'm going to break up that interval at 0, and I'm also going to break it up at 7.5 because those are my vertical asymptote and my x-intercepts. So we're going to go from negative infinity to 0, from 0 to 7.5, and then from 7.5 to infinity. Our factors in this case, from our equation, we had x on the bottom, and we also have negative 20 plus 150. So we'll put those in here. Whoops. Negative 20x plus, whoops. Plus 150. So negative 20x plus 150. We're going to find our factors for these. So across the top we have x. Well, x is negative here, x is positive, and positive in those two intervals. For negatives, well, in this case, if I multiply negative 20 times negative, we get positive. Positive times 150, I'm also going to get positive, which results in a negative. For the second one, if we have something like 2.5 or 5, for example, if I put that into our equation, I'm still going to have a positive answer here, which results in a positive. And finally, the last one we have, if we have a very big positive number, so for example, 25, that will result in a negative here. We have a negative here. So which of these is right? We're going to have to go back up to our final question, and we want to know when is our equation that we have here less than 0. How many games do we need to produce? Well, it's either negative amount of games, that doesn't really make sense, or more than 7.5 games. That one makes sense. But we can't make negative games because in this case, x is an element of negative infinity to 0 and 7.5 to 0 to infinity. But we can't make a negative amount of games. So this one does not make sense. This one does not make sense because we can't make a negative amount of games. So how many games does he need to produce in order to keep his average cost under $100? Well, he needs to make more than 7.5, which is 750 games. And I'll write that up here. Therefore, needs to make more than 750. It's 750, remember, because x is in hundreds games. And that's to keep the average cost under $100. And that's the question that we have there. I know I kind of zoomed in a little bit there, but you can pause at any time, you can have a look. Or go back. There's a few questions in your book for word problems down at the bottom if you want to give them a shot. But that's the end of Chapter 5, solving rational equations, inequalities,